Over the last 50 years, the average near-surface temperature of Alaska has increased at a rate greater than twice that of the average global temperature. This increase in temperature has led to the melting of Alaskan permafrost, which results in an increase in the release of methane and carbon dioxide. These greenhouse gases cause a positive feedback amplification mechanism that induces additional warming and resists the potential to limit global temperature changes. Anthropogenic climate change, notably due to human-induced greenhouse gas emission, is proposed to be the major contributor to Arctic surface temperature warmings, glacial and sea ice loss, and northern hemisphere snow decline. The Alaskan climate system is the most vulnerable to the rise in surface temperature that leads to a decrease in ice and northern hemisphere snow. In fact, the Alaskan coast has experienced the fastest loss of sea ice, based on an annual average sea ice decreases of 4.1 to 4.7% per decade, compared to the observed 3.5 to 4.1% decrease in Arctic sea ice per decade. Alaskan surface and atmospheric temperature increases that cause the melting of sea ice and snow have a profound effect on the exchange of mass and energy between the surface and the atmosphere, which strongly influences cloud formation and coverage. The changes in Arctic sea ice cover also influence humidity, wind patterns, thermal stratification, ocean temperatures, and ecosystem productivity. Characteristics of sea ice, such as thickness, age, and volume, have all been affected by the increased warming in Arctic regions, which can be observed by a decrease in the mean thickness of sea ice, which was 7.5 feet thick in 1980 and decreased to 4.3 feet thick in 2008. The age and volume of sea ice has also substantially decreased from 1980 to 2016. In 1980, 55% of sea ice was first-year sea ice, and ice older than 4 years accounted for 16% of sea ice, whereas in 2016, 78% of sea ice was first-year sea ice, and only 1.2% of the ice pack was older than 4 years. These changes in the volume and age of sea ice suggest that the sea ice is melting and becoming increasingly vulnerable to further melting. The salinity of the Arctic Ocean has had a large influence on the freezing temperature of sea ice. The increase in river runoff, melting of sea and land ice, changes in freshwater transport, and evaporation have influenced the observed decrease in Arctic Ocean salinity. As a result, the acidification of the Arctic Ocean is increasing at a faster rate than the rest of the globe. The ecosystems off of the coast of Alaska are especially vulnerable to changes in ocean acidification due to their extreme sensitivity to changes in sea ice chemistry, respiration of organic matter, and increases in river runoff. The large melting seasons of sea ice loss increases ocean acidification by lowering of total alkalinity, initiating increased upwelling, and influencing the primary production of ecosystems off the Alaskan coast. The Alaskan coast will experience the largest changes in pH, which is proposed to have a substantial impact on coastal ecosystems in the near future. The general increase in Alaskan temperatures associated with warmer and drier conditions, shorter snow cover seasons, and anthropogenic forces has made Alaska more vulnerable to wildfires. This is suggested by the observed increases in wildfire season length and severity in the boreal forests, Canada, and the Arctic tundra. These regions are especially susceptible to wildfires because they contain a large amount of global soil carbon deposited in permafrost. Wildfires lead to increases in warming via positive feedback due to the degradation of permafrost and the release of atmospheric carbon dioxide. Blackening of the ground, which reduces surface albedo and increases permafrost melting, and the removal of protective vegetation. Alaskan communities will experience both positive and negative impacts due to the predicted increases in temperature and the melting of sea ice. Positive impacts include increases in economic diversification, accessibility to offshore mineral and energy resources, agricultural production, forestry, marine shipping, tourism, and decreases in heating energy demands of up to 15%. Negative impacts of warming include the destruction of bridges, drilling platforms, pipelines, and hydropower caused by the melted sea ice. In addition, the melting of ice roads will disrupt the current means of communication between settlements, which will impose economic costs and human risks. The melting of sea ice will further negatively impact food security, health, and the well-being of indigenous communities by altering their resources, such as marine animals, which may further impose an economic dilemma. The melting of sea ice is also proposed to increase the tourism in Alaska, which may lead to increased pollution, introduction of foreign species, and a reduction in Antarctic krill due to the increased tourism